This is Professor Derf Seitz. This Java tutorial focuses on strings from a primitive usage perspective. Although strings are objects, they have a basic usage that is similar to a primitive type. We will learn more about strings as objects in a later tutorial. We have a class, primitive strings, with a main method. First we declare a character called A with a value of A. Note the single quotation marks that enclose a character literal. We also declare a character B and give it the value B. Next we declare a string variable. Notice that the word string starts with a capital S because string is a class, whereas the chars, ints, doubles are all primitive types. They're not classes. However, the string object, the name of that variable, since it's an object, begins with a lowercase letter. Remember that identifiers in Java are case sensitive. So capitalization and versus lowercase produce different identifiers. The string here, it's initialized just like a primitive would be initialized with an assignment statement, but it has double quotes on either side of it. And notice that inside the string many characters appear because strings represent text. Strings effectively string characters together. It's like stringing beads together to make a bracelet. Text is so necessary in computing for documents, for communication. It was not going to work just to deal with single characters. We had to have a text type, and string provides that. Next we have some other supporting data types here that we're going to use in this small program. We have an int called SumInt with a value, a long with a value. Note the capital L in the literal for the long. If we were to take that L out, then it would interpret this literal here without the L as an integer. However, this value is too big for an integer, and a syntax error would occur saying that there's a value too large for an integer. So we'd have to use the L here to define something that big and then assign it in the initialization statement. Next we have a double. We prefix it with a prefix of D for double. The name of the double is E because this is an approximation, although quite precise, to the math symbol E, the base of the natural exponent base. And we also have a string version of E. Notice the difference here. The double is a number, but the string we've prefixed it with an S. It's text. It's not a number at all. Then we have a double for pi and a string version of pi. Note that a string cannot span more than one line. Here is an attempt to begin a string on one line here. This string spans more than one, and to continue it on another line. That's not going to work. Let's go ahead and compile this. And we see at the top up here it says unclosed string literal. This string spans more than one. Strings cannot span more than one line. Let's comment this out and show the right way to do it. It says to span more than one line, multiple Single line strings must be concatenated together using the string concatenation operator, which is a plus sign. It's another way that strings are similar to primitive types by the use of the simple plus sign to add them, which concatenates or pastes them together. So here we have a string called S more than one line 2 to differentiate it from this other one, which ended with a 1 up there. Note the prefix S here is used to indicate a string object. And we have one string with quotes on either side, the string concatenation operator, and then on the next line the rest of the string. Here we have string part 1, the apple tree is space, and part 2, ripe with fruit. And then we declare a string called S combined that we do not initialize at all. We'll use this shortly in the program. Here is a string with embedded quotation mark. Since strings begin and end with a quotation mark, a double quote, how would you put a quote inside a string? The way it's done is you precede it with a backslash character and then the quote. That tells the compiler that this is not a string delimiter, but it's to be treated as a literal string character inside the string. Next we have a string with some new line characters in it. A backslash n is interpreted as a new line character, and in the output it will put the strings, when they're output, it will do a line break at that point. Next we do a little processing, one line. We take S combine, that string, and assign it. We take S part 1 and concatenate it with S part 2, which should give us one longer string, and we assign that to S combine. This usage is very similar to what we do with primitives. Next we have a number of output statements. We're going to use print line to this console, the command prompt. We'll print out strings that give the names of the variables and concatenate it with their values all the way down, the A, the B, the alphabet, all the way down, and we'll see what the output looks like. First I'll save the change I made with that quotation there. We'll compile this. It compiles, and run it. Bring this output window into view to make it a little longer so we can see it all. At the top we see A equals A, B equals B, alphabet, there's the letters in that string, the sum int, the sum long. Look here at the E as a decimal and E as a string. As a string, it's just going to print all those characters. As a decimal type, decimals can only store a certain number of significant digits, 16 in these examples here. So that's why you'll see a difference in what can be output between these two. Similarly for pi, the same thing happens. Here's the string that in the editor span more than one line, but it's still just one string using this string concatenation operator, and it prints out here as one string. Here's our combined string where we took the two parts together. We get the apple tree is ripe with fruit. Here we have the embedded quotation mark. You can see it right there. And this one we have the new lines that make the string break at several places. So we'll close that and go back to our program. And we see how strings at a very basic usage level are very natural to use with initializations and concatenation with a plus sign, very similar at this level to primitive data types. They are objects, however, and in a later tutorial we will be looking at many more features of strings that allow us to go through them and look at the characters in them and find substrings and things like that.